Hello everyone, welcome back to my YouTube channel, and today we are going to make the ML workflow for predicting the energy consumption in power plant through Vertex AI, and we learn how the Vertex AI and AutoML works. So this is the data that I have for power plant cycle, which shows the temperature, vacuum, pressure, humidity, and power outcome, that is the main features that has been used for running a power plant. So we'll directly jump to Google Cloud. Here we'll search Vertex. We'll go at Vertex AI platform, try it in console, and here the Vertex AI dashboards opens up. I've already created my account, but you can simply log in with your Google account and you can use the free 20,000 credits to build your model. In this, we'll first upload our dataset. So I already uploaded some dataset for training, but we'll create a new one from very beginning. So let's name this a power plant model. Now we will select the tabular because our data is in table format, with a regression or classification because the data we have is supervised. The data set has been created. Now we'll upload the data. We'll go with uploading through our system. So this is our CSV file. We'll browse the storage path and continue. These data are on calculation right now, but we already have some sets prepared, so we'll go with that. So this is the same data. Here you can see the total number of rows are 9,568, and we have 5 main column that is features, and these are the distinct value of each feature that we have in our data. Now we'll go on training and train our model through AutoML. We'll go on train new model, then we'll select the model objective. Okay, supervised machine learning is divided into two categories, that is classification and regression. We use classification when we have to classify the objects and we have different classes in which we can put the objects. But here we have numeric value data for which we'll use the regression. Train new model, we'll name the model target column. Target column is very important because on the basis of your target column, the ML model will analyze the different features that you have in your table. So in this data, P will be the target column because this is the power consumption and these are the features that influence the power consumption. So we have to analyze which factor, that is temperature, vacuum, pressure or humidity, affects the most for power consumption. So our main target will be PE and rest will be the features that will help us predicting which affects most and which affects least. We'll select here PE and continue. Others are features that will be included in our training model to analyze how they are affecting the target outcome. Let's set budget to 1 and start training. Now your model will be on a progress, and once you refresh it, the status changes to training, and now your model will take approx 2 hours to get fully trained. But I already did that earlier, so let's analyze this data. When you will click on the training model, it will redirect you to model registry, and here you can see the very first version of model that has been evaluated through AutoML. And here are the evaluations. Our target column is power outcome, The factor which affects the ML model a lot is R square, which shows the variation, and here it is 0.961, which is equivalent to 96.1% model accuracy in variation. So our model is 96.1% accurate, which is a very good rate of success. So here you can see the most effective feature that influences the power outcome is temperature. The importance that is given to temperature is 60%. So this is the highest affecting factor in our power consumption when the turbines work, followed by vacuum, that is 24%, pressure, that is 8%, and least is humidity with 6.8%. So this table concludes that temperature is the most affecting and decision making factor while running a turbine. After this, you can deploy and test this version, or you can create more versions of this. You can also export this data and use it wisely whenever needed. So this is it for today, guys. See you next time.